Okay, so from our circle we need to identify the center. The center is literally the center. Okay, from here I'm going to identify what a central angle is. A central angle is any angle that extends from or puts their vertex at the center. Okay, so if I made an angle here, that is called a central angle. This angle right here is called a central angle. The arc that it creates, okay, this point to this point along the circle is called an arc. If it is smaller than 180, if it is less than 180, it is called a minor arc. If it is greater than 180, it is called a major arc. If it is 180, it is called a semicircle. It just means a half circle. Okay, so I am going to label a few things here. So I'm extending this arc measure all the way through. I'm going to label my outside points A, B, C, and D, starting up to top left. A, B, C, and D. I'm going to go over a few general definitions real quick. If this is 30 degrees, what is the measure of this angle right here? 30 degrees. What is that called? Vertical angles. It's called vertical angles. They're directly across from each other. Now, if this one is 30 degrees, what do I know about this angle right here? This one and this one together equal 180, right? So, what is the measure of this angle? 150, right? All I did was subtract the angle that was already there. So if this angle is 150, then what is this angle? 150 as well. And those are called what kind of angles? They are called vertical angles, as I just stated a second ago. So these vertical angles are congruent always, okay? That is just a little bit of a reminder. Those are some of those definitions. Okay? Yeah. Okay. I'm going to write down a few of these arcs or different types of arcs, and you're going to tell me if they're a major or minor arc, okay? So, and this is how you would write them down, so be careful on your annotation. AB is an arc. So see how the arc is above it there? So when I indicate an arc, I put an arc above it, okay? Now, arc AB is a minor arc. If I wanted it to be the major arc AB, then I need to say one of the two angles that make that major arc. For example, I could say ADC. Arc ADC is a major arc. Okay, that means it's bigger than 180. Okay, so let's see if we can figure out a few of these. If I say that again, Paul? Yeah, it's really easy. If I say arc BD, what is its name? What kind of arc is it? It's a semicircle. It goes halfway around, right? So semicircle. And those are the three different types that you're going to see there. So I'm just going to start naming off a few, and you tell me what they are. Okay, you can say it collectively as a class, or whoever says it, whoever finds it first. Okay. So I have arc ABD, minor, major, or semicircle. ABD. It's major. Arc AD. Yeah. AD. It's minor. AC. Semicircle. Goes straight to the center, right? Yeah. Okay. If I say arc BAD, it's a semicircle, right? Arc BAD is a semicircle. Now, if I said arc BD, that would be exactly the same, right? Because it doesn't matter which way I travel. I can go BD around this way. I can go BD around this way. All I'm indicating when I say arc BAD is that I want you to go to the left. Okay? That's all I'm indicating. It's telling you what direction to travel. Okay? Any questions there before we move on? Just a reminder, these are all central angles. They're measured from the center. That's why they call them central angles. Let me make sure I didn't miss any. No, I didn't. Okay. Just another reminder, how many degrees are in a full circle? 360 in a full circle. So keep that in mind on these future questions. Okay. So on example 1, they give you that circle there, so make sure that you can see it. In that circle, it asks us a few specific questions, so we're going to try to answer them. I'm going to make up a few and then we'll go from there. So I want to know what the arc measure, okay? I want to know what the arc measure would be for arc AB. 90. Remember that central angles are the same as the arc measures, okay?
90, 90, 180.
You said 90, 90, and 180. That's good. Okay. Now, if I said, what is arc BAD in this one? Is it a what? BAD. It's a major arc, just the bigger one, right? Nothing crazy there. And why do I know? He already told me that this one was 90. He told me that angle CPA was 90. How do I know that?
Yeah, it makes a perfect L.
Because it makes a perfect L, yes, that means it's a 90-degree angle, okay? So if this is a straight line, which it is, right, and this is 90, the straight line has 180 minus 90 is 90, so it's left with 90. That's where I should have got that from. But yes, it does make a perfect L. But we can't just trust that perfect L isn't just an 89 degrees. We have to have this angle in here that tells us that it's 90 degrees. It's perfectly right, okay? Questions there? That was relatively quick. Example 2. We're going to find the arc measure. This one, again, is really kind of quick. So it says, what is the measure of arc AB? Looking at your picture. 35. It's that simple. Now, this one's a little more difficult. What is the measure, now noticing the difference, of arc ACB? Arc ACB.
So we take 100 and we take 365 minus 35?
360 minus 35, yes. So 325. So all we did was take 360, because that's a full circle, and subtract 35 from it, and we get what's left, right? And that's all. Fairly easy. Do we have any questions? Okay, these are kind of quick, so I don't want to get anybody confused, but I don't want to waste too much of y'all's time so you can get it done and not have much homework. Alright, we're going to talk about what are congruent arcs, okay? So on example 3, I'm just going to read it out loud and write it down. The measure of DE is given by the expression 3x plus 10, and the measure of HJ is given by the expression 5x minus 40. It is given that DE, arc DE, is congruent to arc HJ. If they're congruent, what do we know about their equations? They are?
They are congruent.
If they are congruent, they are what? Equal, right? Congruent is basically the same as equal. So if they are equal, I'll let them be equal to each other. And then I just solved it. And that's relatively simple. We've been doing that for a while. I want to move my variables to one side and my numbers to the other. So which variable should I move? The 3x one. So I'm going to move the 3x. Why would I not want to move my 5? Make it into a negative. And that means since I moved it to the right, what do I want to do with my stuff on the right? It's just a regular number. Move it to the left. I want to go opposite, right? Okay, so now that's canceled out. I have 50 on this side. Equals 2x. Now what's my next step?
25.
Divide by 2. Good. So x then has to be 25. Questions? Remember, if somebody says congruent, they really just mean equal. Okay? So arc addition postulate is really simple. It makes it sound really complicated because they say arc addition postulate, but really it's just addition. Okay? Arc addition postulate is just addition. If I said, what is the measure of arc ABD, all I'm going to do is take the little arcs that make up that big arc and add them all together. Okay? So if I'm looking at ABD, I'm going to add up arc AB, which is 150. I'm going to add up arc BC, 30, and then CD, which is 150. So I have 150, 150, and 30 that need to be added together. and then I'll just add them together. It's just saying that if you need to add them together, that you can, basically is what it's saying. Okay, so on example 4, we're going to use that idea there. Okay, so I'm going to zoom in on this. And it says, using the arc addition postulate, write an expression to represent the measure of AC. AC. All right, so here we go. Here's our picture. AC goes through AD, and it goes through DC. So what am I going to add together?
80/35.
80 and 35. Simple enough, right? And when I add that together, I get 115 degrees. Don't forget your label. It's very important that you write that down. Okay, any questions there? It's really that easy. If I want to find AC, I just add them together like we did, right? If I want to find the measure of, let's say, AB, how would I do that? Is that a major or minor arc, first of all? AB, is it a major or minor arc? No. It's a minor arc, right? Because if I don't say one of these letters, it's not a major. Okay, anytime you see a major arc, it's going to typically have 3 letters in it. Okay? Actually, I can't think of a single time when it hasn't. So if I'm finding the measure of AB, when you see a major arc, it typically has 3 letters that describe it. So you know which direction to go. Because if I say AB, we're going shortest distance. If I say ADB, then it tells me that I'm going through that way. Okay? So if I'm finding AB, it doesn't tell me that right here, right? It just says that it's P. It just says P. But I do know that whatever the angle P is, plus 80, plus 35, plus 95, I do know that that all equals what? 360. So I can solve that problem by adding all of this stuff together. Okay, so I'm going to add 35 and 90 together first. That gives me 130. 130 and 80 give me 210. And then I have plus P in here. That all equals 360, and then I just start solving. So subtract 210 gives me 150. So P then equals 150 degrees again. Okay. So since P is 150, what is the measure of arc AB? If P is 150, it's 150, right? Degrees again. Okay, I feel like I guys grasped that concept a lot better than any other one we've done. So do we need to go over any more? All right, cool.